We just talk about 5G capabilities and how they're always evolving with new 3GPP releases. But let's understand what was the vision. So, like, what 5G was planned for. Like, there was a wild discussion in industry and academia of what 5G should be, and 5G became a very ambitious project to really bring new use cases. And there were so many new use cases that they had to be classified and organized in three different big areas so that it was easier to define networks and requirements and everything. So the first group, eMBB, Enhanced Mobile Broadband. This is like the natural evolution of 4G. So it's still about mobile broadband, still about, for example, the usage of smartphones when you are in the movement, but that's an enhanced service. So you can have higher data rates, you can have more capacity. The second group was already emerging during the standardization of 5G, but it was thought that 5G should bring it to the next level. That's the communication between machines, and there's many names for that. In the ITU, that's called mMTC, Massive Machine Type Communications, but there is also the usage of M2M for machine-to-machine communications, and that's also related to IoT, the Internet of Things. The third group, we can think of it as really ambitious and completely new. It's URLLC, ultra reliable low latency communication. This is really trying to bring wireless to a level that was not seen before in a combination of two very difficult metrics. So reliability and latency. You can more or less easily achieve reliability if you sacrifice the latency, and you can achieve a good latency if you sacrifice the reliability. But achieving both at the same time was the new target for new types of service in URLLC. Already in the evolution of 5G, it was identified that, well, there is also some things in the middle which the initial 5G specs did not cover so well, and that's called now RedCap or 5G Lite and our Lite. That somewhere in between eMBB and mMTC, so you have higher data rates than the typical machine communications, but you also need to save some energy like the typical mMTC. But let's talk about each of these in a bit more detail. So one of the reasons we had to really separate is because each of these types of services, they really have specific needs, and we need to make some sacrifices in order to achieve the most important metrics of each type. So in case of eMBB, what we are really looking after is to achieve the maximal data rate, the maximal capacity. For mMTC, what we want is the maximal density of connection so that you have really a lot of devices connected in a certain area. And you also need to make sure that the device battery duration is quite high. And for LLC, as the name says, you need to achieve the minimal latency and the maximal reliability at the same time. Let's talk a bit more in detail about each of these 5G usage scenarios, starting by eMBB, the Enhanced Mobile Broadband. So eMBB, it's still the type of user-centric internet access when you are on the go, so like when you're in the movement. And in essence, we are still talking about the traditional types of devices which access the cellular network, like smartphones, like tablets, which can have a SIM card and connect directly to the mobile network. You could also have it on your laptop or use a dongle to have such type of access. And well, we can also use the internet access in a fixed way, so like fixed wireless access. Should not have too many categories. I would like to put fixed wireless access together here because it is still about user-centric internet usage. And the new thing is actually that you can have larger data rates. So you can have data rates, for example, in excess of 1 gigabits per second, which were very hard to achieve in 4G. And with that, you can do things like, for example, you can have more 4K or high resolution video. It was already possible to transfer that with 4G, but actually then with 5G, you can do many more of them. And things like virtual reality, they are slowly becoming more priority. Even though you have also use cases which are more indoors, you can also then extend this virtual reality and extend the reality to outdoors. And according to the ITU, then the main things that you need to take care in eMBB are like data rate and network capacity. You also need to take care of mobility and the network energy efficiency. And those things are then the main points, the drivers for eMBB, but you need then to sacrifice a bit on the latency and the connection density compared to other possibilities. The second class of usage scenarios is mMTC, massive machine type communication. Why do we talk about massive? It's because here we're talking about billions of connections. Like think of many wireless connections. Really, the vision here is to have many more devices than you have humans on Earth, and why you would even need that compared to eMBB, where you have like personal devices where maybe someone has a smartphone, maybe two, and carry them around. Like here, the devices would basically be deployed and would be there in the environment, and they would work without any human interaction. So those are providing services without like really having someone all the time like typing or requesting a page or doing something. Basically, they are just there and connecting and doing what they need to do. And there is many names for such concept: mMTC, M2M for machine to machine, and IoT, which is somewhat larger concept of Internet of Things. What type of devices that we're really talking about here? Maybe the most important group here, like sensors, so devices which collect data of the environment. One example would be, for example, at your home, you could have a temperature sensor, humidity sensor. You can have something measuring, for example, if there is any smoke on the environment. The next type of class of devices is actuators. So like while sensors are collecting data, actuators are actually doing some change to the environment. If you think again of temperature, you could have then not only a sensor of temperature, but some type of actuator which is connected to the heating system or it's connected to air conditioning, and it's going to be able then to lower or increase the temperature of that room, maybe with your control, maybe automatically, depends on how you configure it. The next type of devices are like cameras. Of course, we use cameras to talk to each other, but we also use cameras for things like security and use cameras to look for pets or even like just basically to do some automatic analysis of the environment. Vehicles, they can be now connected and even talk to each other to improve basically the traffic, to improve the safety. So what are like the use cases that we have then with mMTC? One of them is the Industry 4.0, is like the next level of automation that we can have in industry processes. And then we need, for example, a lot of devices to collect data all over the industry to bring them so that we can do some big data processing or that we can even change things like in real time. Next, things like smart cities. You can think of that, of everything which can improve the life of a city. And for example, security cameras, some traffic management that may be done dynamically. You can even have sensors that like look not only for the infrastructure if it's doing well, or for example also to give an alarm in case where you have some type of catastrophe going on the city. You can think anything you can think to make cities more robust, to make them more resilient, to make the life in a city better. You can find applications in smart cities. Then we have smart homes, a type of use case which is mostly covered by things like Wi-Fi, but also we could extend it to the outside with the usage of 5G. We have smart agriculture, that's very important. More and more in the field, we have like precision agriculture, which is like also controlled with wireless, with a lot of connectivity that you have like in tractors and other big machines used in the agriculture. And logistics, of course, the modern life, we depend more and more on logistics, on like bring things quickly to the end user, like to deliver things when they're asked for. And all those things need mobile communication. So like, what are the important things which ITU classified for mMTC? It really boils down mostly to the connection density. Like the idea here was, okay, the old generations of cellular networks, they could maybe have some hundreds or thousands of devices covered by a single tower in a square kilometer, and now you can really have maybe millions of devices. And of course, then it's very important if you have so many connections also to take care of the network energy efficiency. And it's really important for devices which are just deployed there and left that their battery lasts for a long time. But you do sacrifice things. So like when we talk about mMTC, we're not talking about high data rates. We're not talking about very high capacity or low latency or a lot of mobility. Like a lot of the use cases is like when a device is deployed and it stayed there in a certain place. Last but not least, URLLC, ultra reliable low latency communication. This is really demanding and yet to get widespread in practice. Why? Because we're talking about really demanding applications, applications which need immediate responsiveness and at the same time they're not really allowed to fail. If they fail, there is some type of big consequence, for example, related to safety. What type of devices we can think of? We can think of robots which have some human interaction or that do something which is like safety critical. We can think of elements of electrical grid, so like it's more and more that we need some smart management of our energy grid, and those elements may also be connected via a mobile network. Autonomous cars and vehicles, of course, they need to work even if they don't have connectivity, but some of the envisional URLLC cases have been related to this area. Controllers, for example, in an industry plant, that they do a process in a very quick loop, they need to really have a good connectivity, and this loop cannot fail. So applications and use cases of URLLC. First of all, Industry 4.0 already mentioned that we need mMTC, but if you have any time critical part of it, you also need URLLC to take it to the complete vision of the Industry 4.0. Real-time traffic control. So like if you're doing it really quick, you would like it not to fail and to be very reliable. A smart grid, as we mentioned before, so the elements of the electrical grid, they need to be connected, and the requirements of latency and reliability here are very stringent. Remote driving. Imagine, for example, that you would be able to drive a taxi just seated in an office instead of being there in the taxi. Then not only you can have things like more passengers on the same car, you could also have, for example, that the driver takes some breaks and another driver takes over. But for that, you need a very good connectivity between this office where you are controlling the car and the real car, which is there out on the street. And very widely mentioning, but really something that it's more of science fiction yet, the remote surgery. So like that the idea that you could have a surgeon somewhere which is far from the patient and still be able to control all the equipment needed for the surgery. That, of course, should be done only when it's extremely needed. For example, an emergency situation, which is not possible to bring the patient back to the hospital, but it's something which 5G was envisioned for, but will take really long time before that is really possible. And what are then the needs for URLC types of traffic? It's really all about latency combined with reliability and mobility, because if you are on the go and you have this mobility, then this mobility also needs to not interrupt the connection. So like you cannot have a good reliability if every time you move from one place to another, if the connectivity it's destroyed even for some milliseconds. You really need to also pay a lot of attention for the mobility. But you also need to do some sacrifices. You cannot have high data rates and achieve all these latency, mobility, and reliability requirements at the same time. But in all together, all the requirements for these three usage scenarios, eMBB, URLLC, and mMTC, we can understand why they were separate, like even to talk about how to manage a technology, how to plan a network for such different network characteristics would be too hard to do something which does all of that at the same time. And we can see that each of these three areas, like they focus on the different things, which is like sacrifice it for the other usage scenarios. And in fact, 5G really tries to do something new, to have these new areas and really to share the infrastructure, even to provide these three different types of services. But we need to understand there are features and there are devices and services which are more oriented to each of these different usage scenarios.